This video will go over the second semester final review for chemistry. In this first set of problems, you're identifying the number of sig figs in the following measurements. A has 3, both the 2 and both zeros are significant. B, the 0.213 centimeters has 3, all those are significant. The other B has 4, the 1, 3, 1 and the 2 are significant, that 0 is not. D has 2 sig figs, the 1 and 2 are both significant. Okay, when performing the following calculations, the rule for multiplication for A, the measurement having the fewest sig figs, is how you should round your answer. So 25 only has 2, it's 82 meters squared. For B, division, same rule, the fewest number of sig figs. The answer comes out to be 2, but because you have 3 sig figs, you must add the zeros, 2.00 meters per second. For the other B, the addition rule states that your final answer may have no more decimal places than the measure having the fewest, and so you have to the 10th place according to the first measure. And then on D, notice 90 meters is only accurate to 10 meters, so therefore when you subtract, your answer can only be 10 meters, so not even the ones place is accurate. An empirical formula is the smallest whole number ratio of elements in a compound. To perform this type of calculation, you need to calculate the number of moles of each element present. So if you have 38.4 grams of manganese, well, looking at the periodic table, I know that 1 mole of manganese has a mass of 54.94 grams. Grams cancel. 0.699 moles of manganese. Okay, you're going to do the same thing now for the carbon. 16.8 grams of carbon. Well, according to the periodic table, 1 mole of carbon weighs 12.01 grams. Grams cancel. You end up with 1.399 moles of carbon. You're going to do the exact same thing with oxygen. 44.8 grams of oxygen. Every 1 mole of oxygen weighs 16 grams. Grams cancel. You get 2.80 moles of oxygen. Now that you have the number of moles, you're going to divide each one by the smallest, which is 0.699. So divide them all by that. Alright, and you're going to get, this is 1, this is 2, and this is 4. So the empirical formula is MnC2O4. That is the smallest whole number ratio for those 3 elements. This is the exact same type of problem. So start out with what you know. 51 grams of oxygen. Well, 1 mole of oxygen weighs 16 grams. Grams cancel. 3.188 moles of oxygen. You do the same thing now for carbon. Start out with 39 grams of carbon. 1 mole is, let's see, 12.01 grams. So that's 3.247 moles of carbon. The smallest number is 3.188. Divide both by the smallest number. And you end up with 1, and this is essentially 1, it's 1.02, but you can round that to 1, so the empirical formula is CO, carbon monoxide. Okay, to calculate mass percent, first thing you need the mass of the entire compound, so you'll notice I have the mass of potassium, 1 chlorine, and 3 oxygens, so the molar mass of potassium chlorate is 122.55 grams per mole. So to find the mass percent of oxygen, I take the mass of oxygen in the compound, which is 48 grams, divided by the total mass of that compound, which is 122.55 grams, and then multiply that result by 100. You're going to find that this is 39.17% oxygen by mass. This is the exact same type of problem. Aluminum oxide, there are 2 aluminums each at 26.98. There are 3 oxygens each weighing 16, so the molar mass is 101.96 grams. So the mass due to oxygen, or excuse me, with the aluminum, it's asking aluminum, so 53.96 grams of aluminum divided by the 101.96 grams of aluminum oxide times 100. 52.92% aluminum by mass.